In this video, we're going to be learning how to use reference angles for radians. So you might remember this for degrees, and it's pretty similar, but I actually think it might be a little bit easier. So for evaluating trig functions at any angle, just like with degrees, the first thing you're going to do is find the reference angle. So you're going to try to figure out what you're given and which reference angle it relates to. And like I said, for radians, this is a lot easier than for degrees. Then you're going to evaluate the function. So sine, cosine, tangent. Then you're going to determine the sine. And remember, you can determine the sine of the function by using all students take calculus. And the last thing that you're going to do is flip the function if necessary. So remember, we have three functions that we have to flip for. We have cosecant, secant, and cotangent, which are kind of our strange three functions that we learned about a little bit later. So our first one for radian mode, let's say we know tan of 5 pi over 3. So first off, let's figure out where that is. Now, we know here's 0, and over here usually we have pi, but we can write this in terms of over 3 as 3 pi over 3. And then we can write over here 2 pi as 6 pi over 3. So if we're trying to figure out 5 pi over 3, well, that's just 1 pi over 3 less than 6 pi over 3, so we know our function is all the way over here. Now, which function is the reference angle? So remember, like I said, if we just look at the denominator and the pi, that kind of just tells us the reference angle right away. So our reference angle is pi over 3, which happens over here, right? Here's our reference angle. Now we want to know tan. So tan of our reference angle, pi over 3, if you go to the chart and check it out, tan of pi over 3 is square root of 3. And last up, I have to determine the sine, right? So if I think all students take calculus, well, I'm over here. Only cosine is positive, so this is going to be negative. And I don't have to flip because I'm working with tangent. So my final answer is negative square root of 3. Let's try another one. So let's say we have secant of negative 3 pi over 4. So let's try to figure out where that is. Since I'm going negative, remember I'm going clockwise now instead of counterclockwise, so I'm going the opposite way. And here's 0. Here's like pi, but that's also like 4 pi over 4, right? Because 4 divided by 4 is 1. So if I'm at negative 3 pi over 4, that's going to be 1 less than 4 pi over 4. So I'm over here. Remember, you can also use your unit circle to help you out. So you can go back to the notes and check that out. So here we have negative 3 pi over 4. Our reference angle is really easy to spot. It's just pi over 4. And I don't know secant, but I know cosine goes with it. So let's try cosine of pi over 4. And if I look on my chart, that's the same thing as cosine at 45 degrees. So if you know one, you know the other. So this is square root of 2 over 2. Now we've got some work to do. Is all students take calculus? So here, is cosine positive? No. So it's negative. And then I have to flip. So I take this negative square root of 2 over 2 and I flip it. So it becomes negative 2 over square root of 2, and I multiply by square root of 2 over square root of 2 to rationalize. So I end up with negative 2 square root of 2 all over 2, which turns into negative square root of 2. So my final answer is negative square root of 2. Let's try one more just to make sure you have the hang of things. So let's say we have sine of 5 pi over 6. So let's figure out where 5 pi over 6 is. I know here's 0, and I know here is 6 pi over 6. So 5 pi over 6 is 1 less than that. It's all the way over here. So my reference angle is easy to spot. It's just pi over 6. And next up, I'm going to find sine of my reference angle. So sine of pi over 6 in my chart is 1/2. If I try all students take calculus, I know over here it's positive, and I don't have to flip it. So my final answer is 1/2. So that's all there is to it. You do it the same way as you would for degrees, except now our radians are a little bit easier to spot the reference angle.